Hi guys, my name is Thanos, and in this series of videos I will try to navigate with you the world of 3D printing. I have professional experience in this business, and I'm also being a hobbyist for multiple years. I have worked with FDM and SLA, and I will help you navigate the various nooks and crannies of this hobby. Now, in 3D printing, if your equipment is your king, your materials are your queens. They are about the most important thing which influences every part of the process from start to finish, even more than machines. And why do I say this? Materials influence the final quality and the final product. They influence the color, the texture, they influence the probability of a successful print much more so than a machine. Uh, Obviously, you cannot do 3D printing without your equipment, but really your materials give you the depth to bring your creations to life. They are, for most of you hobbyists and starters, FDM and SLA is going to be the thing you guys are more accustomed with and the most common two types of this technology, and I'm going to focus on those two. Let's start with FDM. There are two pieces of paper that the manufacturer provides to you that you really should always defer to, which will give you an understanding of whether or not this material is appropriate for the use. Now, I have already skipped the part, do you like the color, for instance, because this is really down to each individual preference or whether the different materials may give a different finish, such as a silk red or a marble red or a matte red. All of them are going to give a different finish. But really, there are two pieces of paper that give you objective information regarding your filament in the case of 3D print of FDM 3D printing, or your resin in the case of SLA printing. That is the TDS, the technical data sheet, and then it's the MSDS, that's the safety data set. Or you're gonna hear it being described as a safety data set. What is the TDS? The TDS literally is a piece of paper that's giving you a bunch of chemically relevant as it pertains to the properties, to the resistances of your filament, to acids, to alkalis, to organic solvents. It gives you information regarding important pieces of the thermal profile of your filament, the TG, which is the glass transition temperature, which is a temperature in which you are having your amorphous solid going from the solid state to a flexible, I would call it, state, really to be easy and to colloquially explain it. It's not really liquid, but if you keep on applying heat, eventually it's going to liquefy. The best way to describe it is you go from a solid amorphous material to something that almost feels like gum, like rubber in your hand. Obviously, this is a gradual phenomenon, but if you it is relevant to its mechanical properties. You have your heat deflection temperature, which is a temperature in which your filament melts. Now, what we take care about this? Let's say you want to do some small molds, for instance, to do some small manufacture. Maybe you want to do 10, 20 of intricate pieces and intricate design, and you want to mold them, do a DIY home mold. If your heat deflection temperature is lower than the material you're going to use to cast them with, then the casted material and your mold are going to be one piece when you're finished. If not, you're going to have, or if not, you're going to have complete failure. So your heat deflection really talks to the ability of the mold to deal this process. You may also have phenomena in which, let's say, you have a part and there has some degree of functionality. If you are going into its heat deflection temperature, maybe let's say it's not really there to support weight, but it's supposed to, let's say, move and is in contact with the material, and they all have heat deflection temperatures that are close to each other, you may have a situation in which they melt together, so you don't want that. That's a heat deflection. You may see mechanical properties like their young modulus, their brittleness, their ability to resist deformation under stress. Usually, there's going to be some testing, and the manufacturer is going to referencing some testing parameters that they use to determine that. It's going to have information. It's going to touch upon safety. That's really, unless you are using ABS or some other more exotic filaments, I wouldn't say it's really an unimportant subject for filaments. But generally speaking, you resin enthusiasts really need to pay close attention to that piece of information. And then the SDS, the safety data sheet, is really a piece of paper that is telling you a number of safety information. What happens if you ingest it, or should you ingest it, or can you ingest it? It gives you information on how to deal with exposure. It touches upon symptoms you may have if you are exposed, particularly resin, and what to do. Typically seek medical advice. And it is also giving you information on its disposal and its safe handling. Now, with resin, I've seen a lot of you guys go into forums, go into groups, either in Facebook, in Reddit, or some other place, and you are asking each other, how can we be safe using resin? Now, I've had professional experience with resin, and resin is a difficult customer. What is the difficulty? Is that resin is very toxic, and the process requires that you have extensive contact with resin and its byproducts. You have the washing step, which really is even if you are very careful, it generally is a very dirty process. The mixture of typically alcohol and resin is a difficult mixture that it really shouldn't come into contact with you or anyone else, and when it's disposed of, it should be properly disposed. There are situations regarding fumes. There is situations regarding even if you have cross-contamination, so resin contaminating things it shouldn't be contaminating, or things contaminating your resin typically in your equipment that really it shouldn't be contaminated with. So resin is a really difficult customer if you are a user, a hobbyist, that you are looking to buy a piece of equipment in your house. If it was me, that's also me, by the way. I don't see, you probably are seeing the AMS there. I have printers in my house. I have printers. That's basically a spare bedroom. Not the best, by the way. I recognize that, but it's a spare bedroom, and I do not operate them if someone is sleeping there. But with resin, you wouldn't be able to do this because I've worked professionally with resin. It's a very messy thing, and even if you are very careful, you need to be using safety equipment. That's literally gloves, that's masks, that's overcoats. That's a piece of cloth that you wear over your normal clothes to protect them from being smeared with resin. And you can develop rashes and allergies really fast by exposure with resin. So if you are not very experienced, or if you are somewhat messy, I would suggest staying clear from resin. So that's what an MSDS or SDS is going to give you, information regarding safety. And when you get those two pieces of information, I'm going to put those examples into the video. What you then do is that you take them together and you start to synthesize them. And what do I mean by that? Let's say you are making a functional piece, and I will probably put up onto the screen a small example, and I'm gonna talk over it. And I threw it away. So let's say you want to make a brace, okay, and this brace is supporting your monitor. You want to create something unique. That's fine. You have to be considerate of this brace. Is it gonna be exposed to, for instance, consistent heating above or close to its glass transition temperature? Because if it does, as you go towards this TG temperature, you're gonna have an impact on its mechanical properties. So you have to take into account if it's gonna get exposed to sustained and repeated cycles of heating and cooling. Is it going to be exposed to chemical or environmental stressors? For instance, too much humidity or too little. I live in Germany. For those of you who don't know, it's raining pretty consistently. It's a very humid environment, especially where I am on Düsseldorf. It's a very humid environment. So if you choose a filament, it should be a consideration. Because over time, especially if you make your part with very little infill, like many people do, and with few walls, you may end up in a situation where it becomes brittle because repeated cycles of heating and cooling, and then absorption of air humidity into the part is going to make it brittle, and at some point it may just break, and your precious monitor hits the floor, and maybe you've lost anywhere from a few €100 to maybe a few €1,000. So this is a piece of it's a path you have to consider when you are designing anything for your home. If you go outside your home, let's say you are making a functional piece for your garden, for instance, or for some other application, if there is exposure to chemical and thermal, maybe it's out the environment, maybe you are in an environment that's particularly warm, and maybe the water has some properties that's particularly alkaline, or you are using some kind of cleaning agent in wherever you've put your piece, whether it's functional or just an ornamental piece. Repeated exposure may cause problems. That can be complete failure, that can be your part failing, that can also be something like the color degrades over time. You really don't want to have a piece that it's one side which is exposed to UV light, which may be exposed to water, which may be exposed to any number of things, has a very dim color, and the other part of it, it's almost like a Scarface, like it's not Scarface, it's Two-Face. It's you want to make adjustments for that to have something that's gonna stay for you for years, because PLA, if you make it correctly, that includes other materials, it can stay for you for decades. So where I was, you are considering the thermal, the chemical, water, acids, bases, other irritants, other problems with your piece. Now we go a little bit deeper. Let's say you want to make a cutter out of PLA or some other filament. Let's say you do this. Is this appropriate? You're going to look into the safety information regarding filament, even a generic PLA that is telling you that it shouldn't be ingested. Okay, let's hold on to that. Now you will go into the technical data set, and you're going to see some information about water, about solvents, about acids. What does typically food stuff have? That sort of things. You're going to have water, you're going to have fats, you're going to have organic solvent, something like alcohol, by the way, guys. So alcohol is considered an organic solvent. So if you use utensils or cutters or something like that, which are gonna hold on to water, especially things you're gonna eventually eat, you or someone else, maybe using a 3D printing without doing secondary steps is not for you. I haven't seen that many people, but I would be very apprehensive to buy something, a cutter, and make it from PLA and use it for my everyday life. So that's another safety consideration, because you could be having small pieces of plastic which are searing off, or you may have large-scale delamination and you end up eating that. This is not a healthy thing. So you take all those things, you combine them, and you say, let's say, and you determine, I want to use this for this application. The temperatures are okay, it's not really exposed consistently to chemical or other chemical irritants or mechanical stresses, and it's worth it, and I go forward. And then you will look into your color, you will look what do you like to do or not, and you can really do all that consideration and determine what's right and what's wrong for you. And really, this is how you use the TDS in those 2-3 examples and your SDS to do good decision for your filament and for your safety. Now, regarding your safety, as I said a little bit before on SLA, because SLA really, as it regards to its functionality, is pretty much the same with filament. You're going to look at temperatures, you're going to look at melting point, you're going to look at chemical resistances. If you want to use some specialized application, you're going to combine all that information. If you want something really, really high-end and functional, and you're going to choose it. But then you go to the safety with SLA, which is a very difficult thing. So you're going to look at the SDS, you're going to look at the contents, their classification of the chemical contents. You can look at them online, the safety recommendations from other places. Like the Americans have what's called the OSHA, which is basically an organization about workplace safety. the imposed regulations. This is a good place to start if you are uncertain. You can use the SDS and the recommendation inside that's telling you use gloves, use this, use that, dispose according to those standards, and you can look on online regarding those standards and really inform yourselves about how do you set up a place to do resin printing and how do you set up a place to do FDM printing, what are the restrictions, constrictions, and because of the materials, by the way, the materials and the technique, because it's a chain, okay, it's not one thing, it's a chain, it's the materials as a second step to your technique and your technologies and how they inform your decisions. TPU for FDM, for instance, is very hydroscopic, a lot more than PLA. That doesn't necessarily mean you can throw PLA wherever, but that does mean that if you want to use TPU, you may want to do a little bit more drying. You have to keep it and in a very, very dry environment. You have to take a lot more steps. Resin, for instance, doesn't really go well with very high humidities as well, because you can have water being absorbed into the resin, which changes its optical properties, which are extremely important for your end product. And what does that mean? Because this sounds like a very technical and a very abstract thing. If you absorb too much water, you may have a very flabby looking print. It is gonna look like it's a wet noodle, even if you didn't want that, and it may be an irreparable damage. So, and that is because water got absorbed into this mixture and its optical properties changed, but you couldn't really account for that, and it ended up creating this situation in which you want to get an erect soldier, and the soldier is above 40 years old. Okay, and that's how you end up having a situation in which it doesn't really work as it should be. So, from my professional experience, generally speaking, do not operate those machineries near where you sleep, when you sleep, especially SLA, and FDM is a little bit more forgiving, but not that much. Make sure to aerate the spaces, especially for FDM. And for SLA, you will really want a space that has somewhat of a controlled climate, not too high of air humidity, that sunlight doesn't easily, stray sunlight, find its way into your space, because resin, guys, is very, if it starts polymerizing, it's very difficult to, it stops, but it's gonna change it, and it's trivially easy in a normal home or a normal space to have some stray sunlight hitting your resin, whereas for your filament you really need to heat it over even PLA above around 100 degrees to even start melting. So in a lot of ways, PLA, unless your house is on fire, in which case you have other things to worry about, it's gonna be stable. But your resin, because there's sunlight everywhere, even on cloudy Germany. Right now it's the middle of the evening, so it's not really it's not really sun. But even in cloudy Germany, there are days with a lot of sun, and you're gonna, if you're not perfectly careful, you're gonna have some degree of polymerization that can start. And so for resin, you want a place that is really secured from really high humidities consistently. So you want dehumidifiers. Ideally, you want to have a degree of good aeration, because you really don't want to also be allowing a lot of fumes to be piling up. So it's a little bit tricky. And you want it to be somewhat protected from stray sunlight. So some kind of spare bedroom or a closet or a small garage place which is somewhat hidden may be a good place if you want to put it onto your house. Again, I wouldn't do it, but there are a lot of you, and you may be a hobbyist and an enthusiast, and it is what it is. From the safety, from my experience, you need neutral gloves, you need overcoats, you need masks minimally. It's a very messy process, and really, I used a lot of alcohol. It does wonders with a good wash. You can really, unless you're making really exotic and really large pieces, you can only really use a wash, and it's enough. And as soon as your alcohol is not cleaning any longer, you just swap out your alcohol if it's old and used, and that's that. And by the way, what does that mean for you to understand chemically used alcohol? There is a property in of solvents I don't remember the name. I will probably put it up onto the screen right here. Okay, probably I did. In which you have a maximum amount of solved material into a solvent before you can no longer solve. You can no longer, if you add more of the solved material, you're not gonna introduce it into your system, into your solution, but it's gonna become sediment. A good experiment for you to see it on your house, and this is a teacher that gave us a very good example for that in the university. You can take out a glass of water, you can start filling it with salt. You're gonna realize that in the beginning your salt is gonna completely dissolve into the water, but at some point you're gonna start seeing sedimentation. That's because you can no longer introduce more salt into the solution. It's filled up, and so your solvent can no longer absorb any more resin. The same thing happens with your resins. At some point, your alcohols or whatever you're using as a cleaning medium is going to absorb too much of that excess resin that wasn't polymerized in printing, and it just stayed into the surface. And you can do a lot of things, and I've tested them to various degrees of success, like letting it sit into the sun for the particles to polymerize naturally. This is a solution that's going to happen, but in my experience, once you've reached this point, you can get a little bit more mileage out of your alcohol, but it's simply better to just dispose of it properly and get new one out. Again, you can take more mileage out, but you cannot really beat chemistry in such a way. And that's pretty much it. So you take your TDS, you take your SDS, you combine them to see whether or not, even as a baseline, those materials are appropriate for the use, and then you pick a color that you like, a company that you like. You can test out a lot of things, and you'll be surprised how different is the red from one company to the other. And pick your favorite and just start printing with it. You're gonna enjoy this hobby. It's a very creative thing. Sometimes I go over all of those things with a large degree, a lot of details, and this may sound a little bit boring, and it may be boring, but once you master the basics, it's like learning to play guitar. You have to learn to play your notes. You have to do the basics, but once you master the basics, you're gonna be absolutely brilliant. And I truly believe, guys, that if you stick together, stick to this hobby, you're gonna be completely taken aback. One of the things that I would say is that it's a very it's a rejuvenating experience to be able to imagine something and create it and go from an idea to a design, and you just see this being created in front of your eyes, and it's 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 amazing. It's a magical thing. It's the closest we can get to being wizards, really. So I'm Thanos. If you liked what you've heard and you'd like me to continue and support me, press like, subscribe, and see you guys on the next video. On the next video, I'm gonna go over some basic software, that's designing tools, that's slicers, what is what for. Now, I will warn you, I'm really a hobbyist. I have some professional experience again, and some experience as a hobbyist, like most do. But generally speaking, we're gonna go over them, and we're gonna start tying together the technology, the machinery. The machinery is gonna be the video after that. We're gonna start tying together the machinery, the filaments, the materials. I mean, the machinery, the materials, the designing tool, and the philosophies about how do you make a good product, or how do you make something that is nice for you, what to consider. And then we're gonna go through some examples step by step, and yeah, it's gonna be awesome. Thank you guys for your time. Once again, my name is Thanos. If you like what you heard, please like and subscribe. It means a lot, the world to me. The algorithm really loves your interaction, and share this video with your friends, and see you guys on the next video. Bye.